Dynamic SQL is controversial, so let me start by defining Dynamic SQL versus Ad hoc SQL. When I use the term Dynamic SQL, I mean creating a SQL statement by building up the text of the SQL statement, then executing it inside of a stored procedure or inside of SQL Server in some way. By ad hoc SQL, I mean SQL statements that are submitted to SQL Server from the front-end application, the client application, instead of calling stored procedures. There are some times when Dynamic SQL is the best way to solve a problem. As a general rule of thumb, I'm opposed to ad hoc SQL because if you don't have a good abstraction layer there protecting your database, it's difficult to make changes in the database later on. So databases that are accessed by lots of ad hoc SQL, either by a client or by reporting or by ETL tools, become brittle over time, meaning you can't change the database schema to keep up with changing business requirements without having a domino effect of broken code throughout the entire system. So that's the problem with ad hoc SQL. So with those definitions under our belt, let's look at developing dynamic SQL. The simplest form of it is just using this execute statement, which will then execute this select statement. So switching to the family database, and then saying execute. The select statement is handled as if it's a sub-batch, and then simply executed. So that is the most simple form of doing a dynamic SQL statement. An improved form is using the SP execute SQL stored procedure. So here we're going to execute this stored procedure and pass to it some parameters. The first parameter is the SQL statement, and notice that we're defining a parameter here and the type of the parameter and actually passing data to the parameter. This improves SQL Server's ability to take the query execution plan, allow it to work with a flexible set of parameters, save that execution plan, and reuse it. So this is an improved way of working with dynamic SQL. And of course, because these SQL statements in both of these examples is just a string of text, we can assemble that text dynamically using string functions. Looking at the next example of developing dynamic SQL code, going to switch to the OBX Kites database. And let me just sort of walk through it before we execute it. We begin by creating a couple of variables. Here's a couple of parameters, initializing the variables, setting the parameters to some sample data. Now we get into the meat of it, actually assembling the dynamic SQL. And if there is a product category, then we're going to go ahead and build with a join. If there's no product category, we're going to select only from the product table. And for the where clause, we're looking at the product name, product code, and product category. This will assemble a where clause dynamically based upon what's been selected. At the very end, it prints out the SQL so we can see the finished dynamic SQL statement, and then it executes it. And let me address the recompile in a minute. Let's go ahead and execute this a few times and see what we get. So with these variables, we get select product name from product where code equals 1001. If we change these variables, and I recommend you go ahead and try that, you'll see it actually generates a different set of code. Now to execute the code, I added this with recompile here. And let me stop and just address briefly how SQL Server actually compiles these stored procedures and query execution plans. When a batch, whether it's a stored procedure or a query, is submitted to SQL Server, the SQL Server optimizer looks at all the code, parses it out, and figures out the fastest way to execute that code and builds a query execution plan for that batch. And then in most cases, that query execution plan is stored in memory so that if another batch comes along that's identical to one that's already been saved, SQL Server can say, I know how to do this, and look at the query cache, pull out that saved query execution plan, and just execute it. That can be a good thing or a bad thing, depending upon whether or not the query execution plan is still valid and still a fast, good execution plan for these new parameters that are coming by. We'll talk about this in more detail later when we talk about indexes. But the point I want to make here is that what works great as an index for one query might be the wrong index for a different query depending upon the statistics and how it works with the data. Let me give you an example. Let's say you're a startup company and you're based, say, in Nyack, New York. And as you're testing your database, all of your sample data, all of your initial customers are just people who live here in Nyack, New York. And if SQL Server builds up statistics and information about that index, it might say at this point in time, 90% of the customers are from Nyack, New York, and the other 10% of the customers are from other smaller towns around here. Then you go public, put a store on Times Square, you end up going to 1 million customers. If SQL Server is still looking at that old statistics or has that original execution plan, it may think that 90% of the customers are still in Nyack, New York. So if the original query execution plan for find all the customers in Nyack, New York assumes that you have 90% of your customers in Nyack, New York, it'll probably do a table scan because it's faster to scan 90% of the table than to do an individual seek. But now that 90% is only 90 people out of 1 million, and it's going to be much faster to do a seek than a scan. The whole point is that one query execution plan may not be the best query execution plan for a different query with different parameters, hitting a different subset of the table, or using a different index. So sometimes it's good to say with recompile, especially when you're doing these execute SQL statements with dynamic SQL.